Welcome back. This is the second part of 6.1, still working on integral rules. We're going to move on. This is much shorter than the last one, to initial value problems. Initial value problems are just ones where we are going to find C. An indefinite integral says, I don't really know what my original function was. I only know what my derivative was. But if I have some condition that says, there's this ordered pair that I know that my derivative goes through or my original function goes through. If we know something about it, then we can solve for that C value. So find the function f if it is known that f prime of x is this function. So I know that if f prime of x is 3x squared minus 4x plus 8, then f of x must have been x cubed minus 2x squared, because the derivative of 2x squared is 4x, plus 8x, plus some constant I don't know. But I know that this original function, see there's no prime here, that f of 1 is 9. That means it goes through the point 1, 9. So out comes 9. If 1 goes in, and I get 1 minus 2 plus 8 plus c is 9. Negative 1 plus 8 is 7. Subtract 7 from both sides. And I get that c is 2. So I know that not my derivative, sorry, my original function actually started out as x cubed minus 2x squared plus 8x plus 2. Our initial value, something that we are starting with, we know that our original function goes through 1, 9. All right. In a test run of a maglev along a straight elevated monorail track, data obtained from reading its speedometer indicate that the velocity of the maglev at time t can be described by the velocity function v of t equals 8t, defined between 0 and 30 seconds. Find the position function of the maglev. So first we have to ask ourselves, what's the relationship between the velocity and the position? The velocity is the derivative of the position. So if what we have is v of t, this is the derivative of my position function, then what I need is big V of t to find my position function, so which is going to be the integral of 8t with respect to t. This is telling us to do something. So big V of t is the integral of this. I must have started at v squared. What do I multiply 2 by to get 8? v4 plus c. We can assume that at time 0, that it started at 0. So or we could just write, assume that position, at time 0 equals 0. In this specific function, if I plug a 0 in for t and my output, I get C equals 0. That doesn't always happen. Don't assume that at time 0, it's always 0. But in this case, we really just have that I probably, maybe instead of calling this big T and little t, sorry, big V and little v, what we're really looking for is P of t. That might be easier. How about that? So then P of t is just 4t squared. We know that C is 0 because my position is 0 at time 0. So that means my constant is just 0. Find the position function of the maglev. Assume that initially the maglev is located at the origin of the coordinate line. So this is my position function. I know that any time t, it's going to be at here. The current circulation, that means how many people are receiving this. The current circulation of the Investor's Digest is 3,000 copies per week. The managing editor of this weekly projects a growth rate. So growth rate should trigger your derivative skills here. The growth rate of 4 plus 5t to the 2/3 copies per week, t weeks from now for the next 3 years. On the basis of her projection, what would be the circulation of the digest 125 weeks from now? So we need to figure out what's the relationship between what we want, which is circulation, versus the growth rate, which is what we're given. So the growth rate will be the derivative of the circulation, right? How fast are my subscribers growing? So that means that my circulation function will be the integral or antiderivative of 4 plus 5t to the 2/3 with respect to t. In order to land at 4, I must have started with 4t. Here we go in your fraction work. So in order to land at 2/3, I must have started at 5/3. What do I multiply 5/3 by when I take the derivative to land at 5? 3. And some constant that I don't know about. Now I know that the current circulation at time t, at time 0, sorry, at t equals 0, is 3,000 copies. So I know that here, in this case, all of these terms cancel out, they're zeros, and I get that C is 3,000. I know in some of our examples, it seems like whatever our initial value is that constant. It's not always going to be true. Please always double check your calculations there to make sure that our C value is going to be right. So now I have that C of t is 4t plus 3t to the 5/3. Come on now. Plus 3,000 is my circulation function. So now I want to know in 125 weeks. So I want to know C of 125. I just go ahead and put in this. Oops, let's not forget our exponent. I think about this as the cubed root of 125, which would be 5, raised to the 5th power. So this is 500. And what we should get is that my circulation at 125 weeks is 12,875 copies. All right, so same thing that we were doing last time. It's just that now, given an initial value, some condition we know about the original function, we're able to calculate that C value and maybe use it in some form to answer a question. So thank you much for your attention. I have set up a Zoom meeting for Thursday afternoon, no, morning, I think, 11:30, for those of you who would like to join, try it out, have any questions. Even if you don't have any questions, feel free to join in, see other people's smiling faces, test out the technology. Thank you guys for being my guinea pigs, and I wish you a very good day.